So in this example, we are looking at the cross-price relationship between two products. Remember that the own price relationship is how the quantity changes relative to a change in the price of itself. Whereas the cross-price relationship is looking at how much the quantity changes given a change in some other commodity's price. Okay. So we're given two demand functions for products A and B, where the quantity is defined using the price of both objects. So quantity A is defined using the price of A and B, and quantity B is also defined using the price of A and B. Okay. Q of A and B and Q of B are the quantities demanded, where P of A or PA and PB are the price of each object. Okay. So we are trying to figure out whether the products are competitive or complementary. Now, to do this, we look at our partial derivatives. We're looking at the partial derivative of Q with respect to the price of B. B. And we're looking at the partial derivative of Q of B with respect to the price of A. So we're looking at how the quantities change relative to the other price changing. Okay. For it to be competitive, our partial derivatives have to be positive. For it to be complementary, the partial derivatives have to be negative. All we're doing is we are taking the partial derivative and we are determining, is it positive or negative at a given point? Now, for this question, we're not given a specific point, but we'll see why. But in other questions, it might be at a specific price point. So given a specific price point, are they competitive or are they complementary? And it turns out that some items at certain price points are complementary, and then at different price points, they are competitive. It could matter on the price. So let's take a look at this example. So if I am looking at the partial derivative of the quantity of A with respect to the price of B, this is equal to, and I'm looking at this expression. Here we're going to treat P of A as a constant. The derivative of 50, which is the derivative of a constant, is 0, minus the derivative of 2A, or 2 of PA, is 0 as well, plus PB, which is plus 1. This equals 1, which is greater than 0. So at this point, one of my partial derivatives is positive. This is making me think competitive. Okay? But remember, in order to be competitive, both have to be positive. So I'm going to take the partial derivative of Q of B with respect to the partial derivative of P of A. And we get that this is equal to 0 minus 0 plus 2. And this is coming from our second demand function. Now this is equal to 2, which is also greater than 0. So now that we have our expression, we just need to finish up with our solution. As the partial, let's draw this out. Or let's as the partials as both cross price partial derivatives are positive, the products are competitive. You could also say something as both partial derivatives are positive, as you could write out the partial derivatives themselves and say as they are positive. The products are competitive, but the important thing is that in order for them to be competitive, both partial derivatives have to be positive, and in order for them to be complementary, both derivatives have to be negative. Otherwise, it's neither competitive nor complementary.